Hello, my name is Blair Thompson of the website www.justblair.co.uk, and today I'd like to introduce you to a little project that I've been working on recently, which is an Arduino based clock. You can see the hardware for the clock here in front of you. Obviously we're still at prototype stage with this, but it's made up of three main elements. First of all, we have a display, which in this case here is a blue LED 7-segment 8-digit display. These modules can be easily purchased from electronic suppliers or eBay, I think is where I got this one. But this has obviously been built up onto some perforated board to get the display functioning. You can see details on the justblair.co.uk site as to how I built this display. You'll see also at the side of the display here we have an IC which drives the display, which is the Maxim 7221 IC. This is a serial interface display driver, which takes a lot of the headache away from driving these displays, because you'll see that the wiring involved in them is fairly hectic. But rather than have the Arduino microprocessor do all of that itself, which is a multiplexing task, we can, with very, very few cables, control the display with the microprocessor. You'll see also here to control my clock, I've used a Rotary Encoder. Now these Rotary Encoders, I have to say, caused me a few problems, mostly just because of how cheap they are. This one's a mechanical Rotary Encoder, which I bought off eBay as it happens, and these ones are probably the cheapest of the cheap. You can buy them for a couple of dollars. The Rotary Encoder itself controls left and right, or spins left and right, but also in this one has a push button, which in my design here is going to be used as a selector or to set the time with. So I've just attached that with a wire to the Arduino. On the Arduino itself, which you can't see underneath here, but there is one under there, I promise you, I've attached a couple of shields. The first shield, the ones which are uppermost, are simply called ScrewShields. If you haven't got these already and you're using an Arduino processor, I can highly recommend them. The ScrewShield just basically has a number of screw terminals on either side, which makes it very, very easy to make a semi-secure connection with, say, your Rotary Encoder or any other hardware, for instance in this case my display. So you can tighten it up, put the cables in, tighten them up, and then it's pretty easy to swap the ScrewShield in and out. So it's somewhere between using a Proto board and actually soldering a shield together. Certainly very, very useful, a bit more durable than using a breadboard, for instance. Underneath my ScrewShields, you'll see that there's a shield that I've made myself. Again, details are available at www.justblair.co.uk. But this shield itself is a Maxim, or holds a Maxim DS1307 time, or a real-time clock. These can be easily purchased from Maxim direct, or you'll get them from major electronic suppliers. It's basically an integrated circuit which controls a clock. It does need a couple of items to make it work. It requires a clock crystal and a couple of resistors and also a capacitor. The DS1307 also has the ability to use a battery backup, which is an ideal thing, so you can set the time, and if the power is cut to your unit, which in this case it will be quite frequently, then the clock unit on the backup battery will continue to tell the time. They reckon that a standard battery would last about 5 years with a clock like this, so you can set it and then not worry about power cuts, etc. It's an ideal unit for this design. The other thing is that I like about this particular microprocessor, or this IC in fact, is that as well as having some storage area for the time that it's calculating, it also has some additional RAM memory on board which can be addressed, and that as well as battery backed RAM. And you'll see in my example, if you go to the website and download the code for this, that I in fact use that RAM to store just one piece of information, which is a wee flag to tell me whether or not I'm in British summertime or British wintertime, because this clock itself is capable of changing the time according to whether it's summer or winter time. So that's the hardware there. The only other little bit of hardware that I've threw in much later on is, I don't know if you can see it on the perforated board, but I also added a photoresistor, sometimes called a light dependent resistor. These are often used to detect daylight. They're not particularly accurate, but in this case here what I'm going to use it for is to display or to adjust my display brightness. So when there's a great deal of light, the brightness of the display will be raised to make it clearer to read, but in the darkness the display will be dimmed so that the display doesn't keep you awake at night. So what I'll do now is I'm just going to power the Arduino up. I had a bit of fun when I was putting this sketch together, because as you can see, let me just reset that, the clock itself has a little entrance pattern. It was just a little bit of fun on my part before it gets going. This is only run the once through the setup, and it's just a little bit of eye candy because frankly I was just playing around with things. So you can see now the clock itself is displaying the correct time, or the time at the moment. In order to adjust the clock, you'll see I'm just going to use the Rotary Encoder, and if I press the Rotary Encoder once, you'll see it goes into set mode. From the set mode there, I can then adjust the Rotary Encoder up or down to set the hours, and then the minutes, the date, the month, and also the year. We're obviously a wee bit advanced there. The last bit here is it asks me for the day, which is a number between 1 and 7. This is important because one of the things that I've asked, or I've got my sketch to do in this example, is to adjust the time according to whether it's British summertime or British winter time. Now in order to do that, the calculation is pretty simple once you get your head around it. The British summertime starts on the last Sunday in March and finishes in the last Sunday in October. So year on year, it's a different date each year. So I had to produce a formula to test this, and one of the ways that we can do so is by taking the day of the month, subtracting the day of the week, which needs to be a number, checking to see if it's less than 24, which tells us whether or not we're in the last week of March, for instance. You can see again this on the sketch if you go and download it. So we need to tell it the day of the week, and once we do so, another animation, and then the clock is set. You'll see after a few seconds that on 5 seconds the clock also displays the date for me, and it just does that ad infinitum. So hopefully you can see my project here. One last thing I'll just show you is I've got a standard torch here, and I'm just going to hold it over the photoresistor, and as you can see, as the light increases to the photoresistor, it dims or brightens the display. This happens instantaneously, so if you switch the lights out, the clock will immediately adjust to the new light settings. Well, that's the clock itself. I hope you've enjoyed this short presentation. As I say, more details on the build itself and the code that I've used are available from www.justplayer.co.uk. Thank you very much for your time.